for lesson 11, we're going to work on seeing structure. And the big thing is here, we have to make sure we know how to factor completely. So if we look, we're going to do a lot of times here with our bigger exponents. So in the first one, x to the fourth plus 9x squared minus 10, we always look for a GCF first. There isn't one. It's a trinomial, so we know we go into our boxes. First term top left, last term bottom right. We multiply our imaginary 1 by our negative 10. So two numbers that multiply to negative 10 and add to 9x squared. That would be a positive 10x squared and a negative 1x squared. And remember, when you put your like terms in, they have to have the same sign as your middle. GCF the top row, x squared times x squared is x to the fourth, x squared times 10, x squared times negative 1, and then we get negative 10. So our two parentheses are x squared plus 10 and x squared minus 1. So again, we have to look now. This first parenthesis doesn't go anywhere. We're going to end up just bringing it down. The second one is the difference of two perfect squares. X squared is perfect, you get x. 1 is perfect, you get 1, and there's a minus sign. So your final answer is your first parenthesis brought down, x squared plus 10, and then you get x plus 1 and x minus 1. And those three parentheses represent your answer. For the next one, n to the fourth is perfect and 81 is perfect. N to the fourth, square root gives you n squared. 81, square root gives you 9. So our n squared plus 9, n squared minus 9. You always want to look. Again, we can never do the factoring to a plus sign. There's no such thing as a sum of perfect squares. But we do have to do n squared minus 9. Square root of n squared is n. Square root of 9 is 3. There's a minus sign. So we get n squared plus 9. And then we get n plus 3 and minus 3. So similar answers for these two, different process to get there. X squared minus 16, same thing. We'll square root. Square root of x to the fourth is x squared. Square root of 16 is 4. And again, we're always looking for GCF first. There just hasn't been one so far. So we get x squared plus 4, x squared minus 4. And just like we had before, bring it down, factor. So the x squared plus 4 comes down. Square root of x squared is x. Square root of 4 is 2. And we get x plus 2, x minus 2. Look for GCF. There isn't one. It's a trinomial, so we'll be in our boxes. Y to the fourth minus 100. We'll multiply our imaginary 1. Multiplies to negative 100. Adds to negative 21 y squared. So that's going to be a negative 25 y squared and a positive 4 y squared. GCF the top row, you get y squared, another y squared, minus 25 and plus 4. So we end up with y squared plus 4 and y squared minus 25. Now a lot of people want to factor out that first one because they know y squared is perfect, they know 4 is perfect. Remember, it does not work with a plus sign. The only one that works is the y squared minus 25. Square root of y squared is y. Square root of 25 is 5. We end up with y squared plus 4 and y plus 5, y minus 5. So very similar answers to a lot of these first couple. In the fifth one, GCF. Okay, anytime you start with an odd exponent, there's usually a good chance you're going to have a GCF. We can actually take out a 2m from all of these. So that's going to go out in front. We get m to the fourth plus m squared minus 6. So now we will look at imaginary 1 to trinomial. So we're going to be in boxes. M to the fourth, negative 6. Now we need two numbers that multiply to negative 6 and add to a 1m squared. Those numbers are going to be 3m squared and negative 2m squared. GCF, we get m squared, another m squared, we get a plus 3, minus 2, and those two multiply to negative 6. Can't forget about our 2, that's got to come down. We end up with m squared plus 3 and m squared minus 2. Now be careful, I know a lot of our minus parentheses have split or have factored again, but In this case, 2 is not a perfect square, so there is no perfect squares factoring to do to that one, so therefore we just stop at that point. Next one, no GCFs, trinomial. So we multiply here, we are 9x to the 4th and 4, multiplies to 36 and adds to negative 13x squared. That's going to be a negative 9x squared and a negative 4x squared. GCF the top row, 9x squared. So that's just an x squared up top. We are minus 1. We are minus 4. So now as we finish, we end up with 9x squared minus 4 and x squared minus 1. Now both of these actually end up factoring further. So 9x squared is perfect. You get 3x. 4 is perfect. You get 2. So you get 3x plus 2, 3x minus 2. And then x squared minus 1, x squared is perfect. You get x. 1 is perfect. You get 1. So you end up with x plus 1 and x minus 1. So what you end up with is all 4 of those parentheses turn out to be your final answer. So again, factoring completely, usually more than once, and you want to make sure you factor until you are not able to factor anymore.